All right, I'm going to do a video for each one of the 2024 FRQs so that when we're practicing this in class, you can get some help if you need more explanation. So the first two questions are always the calculator questions. You get 30 minutes to do these two. You can't skip around in the non-calc part. And remember, we've been talking about this. The FRQs are always set up in the same way. You get the same types of questions. You just have different functions to work with. So the figure shows the graph of the function on its domain from negative 3.5 to 3.5. They're giving us 3 points on here, negative 3, 1, 0, 1, and 3, 1. Remember, you're going to have a work booklet that unfortunately doesn't have the problem on it for you to add stuff to, so just keep that in mind. Function g is this exponential function. H is defined as g composed with f of x, g of f of x. So this first part, A, 1, is always a composition. Find h of 3 is a decimal approximation or indicate that it's not defined. So for part A1, I'm going to kind of, so that I can still see the problem, I'm going to put my work just kind of around the borders here. So first, write out what h of 3 is. So it's g of f of 3. Remember, with composition, you always find the value on the inside first. So f of 3 is equal to 1. G of 1 is 2.916 times 0.7 to the first power. And you can either use your handheld calculator or you can use Desmos. I'm just going to use my calculator for this one. I think you should have both. Bring your calculator in case something is being weird for you in Desmos, and use Desmos primarily if things are easier. So I get 2.0412. Remember, the directions on the test say to round in the nearest thousandths place or 3 decimal places. So we have to round correctly, otherwise they will count us wrong because we weren't following directions. So 2.041 is h of 3. You don't have to box in your answers or anything. That's just something I do out of habit. And then part 2, sorry, I'm not sure why my pen is being so glitchy here. Part 2 says find all values x for which f of x equals 1 or indicate that there are no such values. So they kind of gave us this answer by identifying these 3 points. There's not really work to show, so I don't like just saying my answer. I like to have something. So I'm going to say f of x equals 1 when x equals negative 3, 0, and 3. I believe you can list your answers out like commas like that. I don't think there's any problem with that. Part I, find all values x as decimal approximations for which g of x equals 2, or indicate that there are no such values. Now remember, you can do this algebraically or just graphically. So g of x is 2.916 times 0.7 to the x equals 2. Algebraically would be kind of annoying. I have stuff to keep track of. I could divide by 2.916, and then I could log base 0.7 both sides. But why not? You know what? Let me pull up Desmos just to show you that option. Desmos, the only bad thing about it is that we have a smaller screen on our test, so I'll just kind of do it like this. All right, so I am trying to figure out, I have one function, y equals 2.916 times 0.7 raised to the x power. And I want to know when that intersects with y equals 2. So it's pretty easy in Desmos. To 3 places, this answer comes out to 1.057. So you don't have to show the algebra for how to get there. Let me just double check that again. 1.057. Yeah. So I would suggest solving graphically. You can also do this in your graphing calculator by typing in that same equation and saying it was 2.916 times 0.7 raised to the x power. When is that equal to 2? And if you're not sure what to zoom the window to, I usually go back to standard just to start. And you can see the intersection point there. Second, trace, intersect. Same answer. All right. For the next part 2. Determine the end behavior of G as x increases without bound. Express your answer using the mathematical notation of a limit. Limit notation has to be correct. For some reason, this notation gives some people trouble, like remembering how it goes. We use limits a lot in calculus next year, too. It's the limit. This goes underneath that little lim as x approaches infinity, because as x increases without bound, means x approaches infinity, of what? Of g of x, or write the equation for g of x. What is that equal to? Your only options are infinity, negative infinity, or a number if there's a horizontal asymptote. So if you haven't already, go ahead and graph g of x. You've either done it in your graphing calculator, see how this is going towards 0, or you've done it in Desmos. We can kind of drag this out and see, like, yeah, this is never, it looks like it's hitting 0 exactly, but if you, and it's a little misleading on Desmos because it's showing 0, but it's just because it's not taking me to a lot of decimal places. But if we trace this down here, we should remember on our exponential graphs, if I can get down to the, there we go, trace, sorry. If we should remember on exponential graphs that there is a horizontal asymptote. There's nothing you can raise this 0.7. There's no power you can raise it to get it to be exactly 0. It will just approach 0. We do say equals 0. That's the limiting value. So this is just talking about end behavior. All right, part C is always this question. This is a bit frustrating, but the nice thing is you get 2 points out of this if you do it correctly. Determine if f has an inverse for part 1, and part 2 is give the reason. So part 1 is really just like a yes or no. Instead of writing yes or no, it would probably be good to say, yes, f has an inverse, or no, f does not have an inverse. F is failing the horizontal line test all over the place, so the answer is no. F has no inverse function. The reason for part 2 cannot be because it fails the horizontal line test. That's just our quick visual for how we can answer yes or no. So just describe what the horizontal line test is in actual words. So what does that mean? There are, in this case specifically, when y equals 1, when we have an output of 1, there are 3 different inputs that give that output of 1. So I just say there are multiple inputs that have the same output. And if it's easy to do, like in this case, show an example of that. So for example, f of negative 3 is the same as f of 0, which is the same as f of 3. They're all equal to 1. So I think that's enough to give me the 2 points for that. All right. Question number 1 is always set up like this. The only thing they change are whether they give you a graph or a table here and what kind of equation they give you for G. But we always have these types of questions.